So chapter 7, we're going to look at this scenario right here for today and tomorrow as we start talking about what's known as a sampling distribution. How did students do on the AP Stats exam last year? Specifically, we want to estimate P, the true proportion of all AP Stats students in this district that passed the AP exam, and mu, the true mean AP exam score for all AP Stats students in this district. If you look on page 5 in your packet, you should see a table that looks like this, only on hot pink paper. So go check out page 5 real quick. I pulled this information from another school district where they literally had 253 AP Stats students that took the AP exam last year. This is all of their scores. Does anybody? 216. Does anybody in here? Yes. It's on page 5. Oh, that's a great question. So the AP Stats exam scores are scored anywhere between a 1 and a 5. A 5 would be like the best you can do. A 1 is the, I guess, worst if you want to look at it that way. But you're going to get between a 1 and a 5. A 3, a 4, or a 5 is considered passing. If you get a 3, 4, or 5 on the AP Stats exam, you can take that test score to the college that you're planning to go to, and most of them will give you credit for an introductory statistics course if you get a 3, 4, or 5. If you get a 1 or a 2, that does not mean you wasted your time, especially if you still have to take statistics in college, because you will have seen a lot of this information, and it's going to be a lot easier to pass that class in college since you've already had exposure to all of those concepts going in. But yeah, 3, 4, or 5 is a passing score here. Can I get a volunteer to calculate the true proportion of all AP Stat students in this district who passed the AP exam? So you need to go through and find all of the 3s, 4s, and 5s. Can I get a volunteer? You want to do it? For reals? Yeah. All 253 of them? Yes. I don't want to do that. Does anybody feel like volunteering for finding the true mean? Add up all 253 scores. It would take a long time, right? You would do it? What we're going to do instead is we're going to take some samples so that it's much faster and easier to calculate these proportions and these averages. So all 253 scores are on page 5, and they're also right here in this dot plot. What do each one of these dots represent? Yes, a student's AP exam score from one student in this district. We call P and mu parameters. These come directly from the population. P is the true proportion of all the AP Stats scores. Mu is the true mean of all AP Stats students in this district. Whenever we're looking at a parameter, it is the true whatever we just calculated for the entire population. And I think we were just able to see the problem with actually calculating this. 253 is not exactly a large population, but going through and calculating the true proportion is going to take a hot minute. Going through and calculating the true mean, the true average, is going to take a while. And there's a lot of room for error doing that too, unless I enter it all into my computer. Computers make less errors than I do when they're entering stuff into the calculator, right? So instead, we are going to estimate these things. This graph right here we call a population distribution. There is one dot for each of these 253 students. Every dot is one student. We're going to take some samples. I want our samples to be 10 students each. We're going to do this 3 times over. I'm going to walk through exactly what I want you guys to do from start to finish. And then I'm going to set you guys loose to do this, and you'll do it 3 times over. All right, so graphing calculator. On the graphing calculator, we can use this to select a random sample of 10. Does anybody remember how to do that? We want it to choose random integers. To get to that function, to get to the random number generator on the calculator, you start by pushing the math button right here underneath the alpha key. We're going to arrow over to probability. And we have the option on the yellow calculators. The app, you can't do this. It's a paid feature unless you want to pay. But here we can do rand_int no repeats because I want it to select 10 unique students. So I'm going to choose option number 8. Our students have already been assigned a number, right? First student on the list is student number 1, so I want my lower bound to be 1. We have 253 students on the list total, so my upper bound is 253. And I want to choose a random sample of 10, so my n value is 10. So far, so good? All right. This next part, just watch, because it took me a minute to figure it out. We're going to paste that in like this. When I hit enter, it will find my random sample for me. But there's a problem. Can I see all 10 of those numbers? I'm going to have to be able to scroll over. If right here, while this guy is still flashing and you haven't touched any buttons, if you use the left and right arrow keys, you can scroll over. If you push the up or down arrow button, or you hit an enter or anything else, it will no longer let you scroll left and right anymore. So you hit enter, and then you want to get those numbers. You want to scroll from left to right. We're going to go find each of these people on the table.
Is this what calculator?
What's it unhappy about? What does it not like about that? Okay, let me try. Let's try that again. Oh, nope, that's not what I wanted. We want rand_int no repeat. 1, 253, 10. Grab a different calculator. I'll figure out what's going on with that one in a little bit. Okay. So you're going to use this to select your first random sample. Can I get somebody to jot these numbers down for me? Because I literally want to demonstrate exactly what you're going to do. Can somebody jot these down so that I can go and then look them up? All right. 202, 241, 56, 94, 2, 237, 28, 139, 217, 248. Did somebody get all those numbers? You got them all? Awesome. So now what you're going to do, once we have those numbers, scores for each of those students on page 5. So Soliana, if you could read back those numbers one at a time to me super slow. What was the first number? 202. That person scored a 1. All right, what was the next number? 241. That person scored a 4. Next? 56. That person got a 5. Okay. 94. That person got a 1. 2. That person also got a 1. 237. That person got a 3. 28. That person got a 5. 139. That person got a 4. 217. That person got a 5. 248. That person got a 2. And that's it. Okay, so I should have 10 numbers on there that range between 1 and 5 because we're just writing the scores down on the line. Now, for each of these samples, you're going to do 2 things. You're going to calculate the proportion that passed. We said a passing score was 3, 4, or 5. So let's go through and figure out how many 3s, 4s, and 5s I've got. I've got 1, 2, 3, 4, 5, 6 out of 10. 6 out of 10 would be what? 0.6. And then I'm going to go through and calculate the average. So I'm going to add all of those up and divide by 10. So let's see, that would be 10, 12, 15, 24, 29, 31. I think that comes out to 3.1. Can somebody double check mine? Yes, cool. I take your word for it. I want you guys to do 3 samples like that and calculate the proportion that passed and calculate the mean. I'm going to give about, let's see if we can get this done in 6 minutes. I will figure out why it's not working on that. I'll have to look it up. So as you are calculating your proportions and your averages, I'm going to ask you guys to come up to the board and put just the proportions on here. All right, so each of these dots that we just put up is a proportion, right? Proportion calculated from what? What does each of those dots represent?
10 AP students.
A group of 10 AP students. How did we choose them?
They got a passing score on the AP.
They got a passing score on the AP exam, and we chose them by doing randomness. Random number generator chose them. So every single dot represents one random sample of 10 students. And technically this would be the proportion that passed, but we calculated a proportion for each of these groups of 10. Each of these dots is a p-hat. Remember, we said that p was the true population proportion for all 253 students. When we calculate a proportion from a sample, not from the whole population, instead of calling it p, we call it p-hat. This is an example of a statistic. Statistics come from the sample. And this dot plot that we just made isn't the population distribution. This is the sampling distribution. Specifically, this is the sampling distribution of p-hat. We use statistics to try to estimate the true parameter for the population. P-hat is an estimate for what again? P-hat is a sample proportion, but what is it estimating?
Proportion of students passed.
The true population proportion of those who pass the AP stats exam. I can use this sampling distribution to try to figure out what I think the true population proportion is, what P is. If I asked you to look at this and make an educated guess of one number that would represent the true population proportion, what would you guess? 0.6? 0.7? Somewhere between 0.6 and 0.7? You guys feel comfortable? I heard mostly 0.6s, and I agree. The only reason that I'm leaning a little more towards 0.7 is because there's a lot of dots over here. I think that might pull the center up a little bit. This has a mostly symmetric appearance to it, and so we would look at where it's centered. That is probably going to be very close to what the true population proportion is. These means that I had you guys calculate. For a sample mean, we use X bar. Mu is the true population mean. X bar is the sample mean. I'm going to have you guys come up and put your sample means up on the screen. We're going to do another dot plot. Give me just 1 second. All right, go ahead and get this copied into your notes to the best of your ability. This guy out here is sitting at about 4.6. Do you guys want me to read off counts?
Yeah.
All right. I'm going to start on the left this time. Write numbers underneath if you need to. There is 1 dot at 2.3. There are 3 dots at 2.4 and 3 dots at 2.5. There's 5 dots at 2.6, 3 dots at 2.7, 5 dots at 2.8, 7 dots at 2.9, 2 dots at 3, 9 dots at 3.1, 6 dots at 3.2, 6 dots at 3.3, 8 dots at 3.4, 1 dot at 3.5, 4 dots at 3.6, 2 dots at 3.7, 3 dots at 3.8, 1 dot at 3.9, and then 1 over there at 4.6. It looks like, what it looks like to me is that somebody's finger got dragged.
Yeah, my bad.
Okay, no, and that's fine. Like sometimes I know dots end up on top of each other, but that looked like 1 dot that just drug a little bit. What are your 3.1 and 3.3? All right, so now 3.3 has 7 dots. 3.3 has 7 dots. And there's 10 dots at 3.1.
There's only 2 dots.
Which one?
This guy, 2.
At which one?
No, just saying.
Oh, we only added 2 more because she had one of them calculated already. So we just added 2 more dots. What does each one of those dots represent? Is it a proportion this time? It is the mean of a sample of 10 randomly selected students, yes. 1 random sample of 10 students and a mean calculated from that sample. This is the sampling distribution of X bar. Now, to be really technical, this is not the full sampling distribution. This is just part of the sampling distribution. The full sampling distribution would have every single possible combination of 10 students from that group of 253 and an average calculated for every single one of those possible arrangements. We didn't do every single possible arrangement. We just did some of them. In fact, we've got, let's see, what's 24 times 3? 72? We only have 72 of the possible arrangements up here. All right. Big idea time. Go ahead and flip it over for me. We use statistics to estimate parameters. Oh, wait, I meant to ask you one question. You don't have to flip back over. If I were to ask you, what do you think the true population average is? If you had to pick one number for the true population average, you think it's about where?
3.1.
Probably right about 3.1. That's where this sampling distribution is centered. We use these statistics. P hat estimates the true population proportion P. X bar estimates mu, the true population average or mean. And S estimates sigma, the true population standard deviation. Parameters come from the population, and they are often way too difficult to calculate. You can't get your hands on all of whatever group we're looking at. And so we use our samples to calculate statistics to give us good estimations. The sampling distribution is the distribution of values for a statistic, so for p hat, for x bar, or for s, that has all possible samples of a given size from a given population. I want to practice identifying the population and the sample, the parameter and the statistic. We're going to look at 3 different scenarios here. The Gallup organization recently interviewed a random sample of 1,013 adults in the United States and asked them how much annual income their families needed to get by. The average amount for the sample was $85,000. I'm going to start with the easy question. What's the sample? 1,013 adults in the U.S. There we go. 1,013 adults in the U.S. That sample was taken from the population. What's the population? Which adults in the U.S.? All the adults in the U.S. is our population. What did they calculate from the sample? The average, the mean, yes. I thought I heard that being said, but it was really quiet. And what was the average that they found? 85,000. So they found an X bar, a sample mean, and it was 85,000. What's the symbol that we use to represent the true mean? Mu. The true mean would be mu. And this would be the true mean what? Population average of, what is it that we wanted to know about the population? Income. We want to know the true average income or the true mean income. Number 2 is almost the same. What's the same and what's different about number 2? Same sample, same population. And what was different? They gave us the standard deviation this time. What was the symbol that we used for the sample standard deviation? S. And what was the standard deviation that they calculated? 15,300, yes. So S is 15,300. What do we use to represent the parameter for standard deviation? Sigma. And in this case, sigma would represent what? The true standard deviation of income, yes. Yes. So it's technically a lowercase, and I know it's hard to tell on there, but P with nothing over the top is the true population proportion. P hat is the sample proportion. All right, let's look at scenario number 3. Some curious AP statistics students believe that most cars in the school parking lot are silver. They take a random sample of 30 cars and calculate that the proportion of the sample that are silver is 0.36. What is the sample? 30 cars. What's the population then? All the cars in the parking lot, yes. What's the statistic? The proportion, so that would be P hat. And what was the proportion that was calculated? 0.36. So P hat is 0.36. What would the parameter be then? P, which would be the The true proportion of silver cars. Do you guys remember when we did the Beyonce Crazy in Love thing?
Yes.
Okay, so that's exactly what this is. We wanted to estimate the average word length for Crazy in Love. So each of you guys took a random sample of 5 words and you calculated the mean of the sample. And then we used all of your sample means to make a dot plot, right? Would this be a population distribution or a sampling distribution? Sampling distribution, why? What does each dot represent? It's an average and the sample from the sample, an average from the sample. Each dot represents a statistic from a different random sample that was taken. Homework's due on Tuesday. Reading, page 468 to 481. 468 to 481. If you need to snap a picture of that, the board in the back has it written down.